Here is a boring plug-in point, something that we see every day, right? But here is an interesting question. If you look at your plug carefully, you'll see that the top of the top pin is usually longer and thicker compared to the other two pins. Why do you think that is the case? Save us from deadly shocks. But you may be wondering, how can a little feature like making one pin longer can save us from shocks? Well, to answer that question, we need to explore what are the different wires that come to your plug point and what each wire does. So that's what we will do in this video. Let's explore these three wires and then hopefully we'll be able to answer the original question. So let's begin. A wire that comes from one of these bottom holes, one of the wires will be insulated with red color and the other one would be insulated with black color. The red wire is often called the live wire. So this is live, or it's also called the hot wire, and we'll see it in a while why it's called that way. And the black wire is often called the neutral one. So the immediate question could be, why are they having different colors and why are they named differently? What's the difference between these two wires? But when I first learned this, I thought that one of the wires brings the electricity to a house and the other wire, the black wire, will take the electricity back. And so this is how I was thinking. I say electricity comes from the electric poles to our house through the live wire and it goes back through the neutral wire. Simple, right? But that doesn't make sense, mainly because we are not dealing with one directional current. You remember that we are dealing with alternating current, the current which keeps changing its direction. Once the current flows like this, then the current flows in other way. So it doesn't make sense to say one wire brings in electricity, another wire brings out electricity, because the electricity keeps coming and keeps changing its direction. So again, what's the difference between these two wires? Well, it turns out it's got something to do with voltage. If you look at this back wire, its voltage is always maintained very close to the voltage of the ground, and we will see it in a second what this really means. Okay, and that voltage is often taken to be at zero, and if you look at this live wire, it has a very high voltage. So this, it just happens to be 220 in India. But again, what does that even mean? Well, that means if the current is flowing say in this direction, then this wire must be having a high voltage compared to the ground. We usually call that as positive voltage. But then when the current is flowing in the opposite direction, then this should have a higher voltage, right? But its voltage remains the same. Now the voltage of the wire becomes less than zero. It can become negative. So that's why we have negative voltage. And the voltage of the line where swings between positive voltage and negative voltage, making the current alternate. But the voltage of the neutral wire remains pretty much the same. And we can imagine this is to be similar to a slide, one end of which is connected to the ground and the other end is free to move up and down. So when the other end is up, notice the ball goes to the right this way. Now, if I move this end down, the ball comes back. So by moving that end up and down, notice above the ground, below the ground, I can move the ball back and forth, forth and back. So this end is like the live wire. Its voltage keeps going above the ground and below the ground, back and forth, making the current go back and forth. On the other hand, on the other end is like the neutral wire. It's always having the same voltage as that of ground, so that it makes sense. So what does that means now? Though this means that if, let's say, cat comes and touches this neutral wire, and let's say the insulation is broken, right? Then what's going to happen to the cat? Well, over here the voltage is zero, and again over here the voltage is zero even though the ground voltage is zero. Since the voltage of this is the same as that of the ground, there is no potential difference coming across the cat, and as a result there will be no current flowing through the cat, so the cat will not get a shock. But what if the same cat were to go and touch the live wire? Can you guess what's going to happen? The cat is going to have a very shocking experience, because now there is a live wire is either having a much positive voltage compared to the ground or much negative voltage compared to the ground. And as a result, in either case, these charges will flow between the wire and the earth, resulting in the cat getting a nasty shock. And that's why That's why it is called live or hot wire, saying that it's an extremely dangerous wire. So finally, after going all through this explanation, in short, the live wire is at a very high voltage when compared to the ground, but the neutral voltage is very close to that of the ground. Okay, if the two wires are enough to provide electricity, why do we need a third pin, right? To answer that question, let's attach something to this flip point. Let's attach a microwave. Let's say if you could look inside this wire, you'll see something very similar. You'll see two wires, one connected to the live, which is red one, and the other connected to the neutral, and the current flows back and forth between these two. And this is the internal circuit of that microwave, which I've just shown as a resistor over here. And so you're right, only two wires are enough to run this microwave. Then why do we need a third wire? That is in case of a fault. Imagine when this microwave was installed in your home, some mishandling happened, and let's say the insulation of the live wire broke off and starts touching the metallic case. Let's say, so here in the situation, so you can see the insulation has come off and the live wire is not touching the metallic case. Now again, let's bring back our kitty. She's gonna have a bad day today. If I switch on the plug, now what do you think is gonna happen? Well, because the live wire is touching the metallic case and metal is a conductor, electricity will start flowing through the metallic case to the cat and into the ground, again giving our cat a very nasty shock. That is extremely bad. We want to avoid that. How do we do it? That's why third wire comes into place. There will be a third wire which is usually green color, which is directly connected to the metallic ball, and it goes all the way to the plug, comes out of the third pin again. Let's see. And then where does this wire go? That wire eventually comes out of your house and eventually is put inside the ground. And so this third wire is often called, no surprise, ground wire. This is the ground wire or the earth wire. It can also be called the earth wire. So how does that help us? Now instead of the electricity flowing through the cat, that electricity will flow through this ground wire and go directly into the earth. Why it will go through the wire and not through the cat? But because the wire has a much smaller resistance. This entire path has much smaller resistance compared to the cat. You might know already that electricity tends to flow through the small resistance path. So almost all electric current will flow through that path, ensuring the safety of our gifty. So in short, if there is any current leaking due to any fault, the ground wire ensures that we don't get electrocuted. A quick thing, not all the plug points have a 3-pin, right? For example, mobile chargers and say my MacBook charger has only 2 pins. And what's going on there? Well, that just means that the amount of current we are dealing with over there is so minuscule that even if we get a shock, it's not a big deal. So it's not worth investing in putting another pin. In fact, my MacBook does give me a shock every time it's charging. Yes, that's all right. So only when we are dealing with high currents, high power devices, that's when the third pin becomes super important. So with that, let's come back to the original question. Why is the top pin, which we now know as the ground pin, why is that always longer and thicker than the other pins? Can you please pause and think about this? Well, if the ground pin is longer, then that means when you're inserting it's the ground pin that gets connected first, meaning our device is made safe first, and only when then these two pins get connected, meaning only then the current starts running through this device to ensure that we will not get electrocuted in any case. And similarly, when you are removing the plug, again we are ensuring that the ground is the last one to get disconnected. So we first disconnect the electricity from the device and then we disconnect the safety, the ground wire. This is super, right? And of course, the ground pin is also made thicker to ensure that we connect the plug in the proper position. In this way, there is no chance that the ground pin will get inserted into the live hole, which can again cause problems.